In this video I'll explain how to graph this function and how to find the different characteristics of the function. First thing we want to do is we want to figure out what the vertex is. We recognize that it's a polynomial function, specifically a quadratic function because of the 2, the x squared. It's a second degree polynomial, and so we know for sure the end behavior of this function because a being 2 is positive and it's an even degree polynomial, so we know that the ends of the graph go up from left to right. In fact, since we know that quadratic functions are shaped like parabolas, we know that all we have to do is find the vertex and a couple intercepts and we're good to go. So to find the vertex, first thing we're going to do is we're going to use our knowledge of when the function is in standard form, we use that x equals negative b over 2a. Now the b is 12 and the a is 2, and negative 12 divided by 4 is negative 3. So we know the x coordinate is negative 3, so we know the axis of symmetry is x equals negative 3, so we can do that right now. Put the axis of symmetry in there. And then if we want to find out the y coordinate of the vertex, I'll do that down here. Y of negative 3, we replace x with negative 3. 2 times negative 3 squared plus 12 times negative 3 plus 21. 2 times 9 is 18. 12 times negative 3 is negative 36. And then we have plus 21. So I'm going to combine the 18 and the 21. 21 and 18 is 39. 39 minus 36 is 3. So the vertex is at negative 3, 3. And again, we know that it opens up, but we can fill in the vertex right now, negative 3, 3. Since we do know it opens up, we're not sure yet what the y-intercept is, but there will be no x-intercept, none. And the domain we know is all real numbers. We know the range would start at start at 3 and go to infinity, increasing. So let's go ahead and find the y-intercept first because it'll be easier when we look at the graph. So the y-intercept, we'll do that down here. So the y-intercept, we let x equal 0. And when x equals 0, we see that y equals 21. So the y-intercept is 0, 21. And when we draw the graph, remember the 2, the a being 2, when it's greater than 1, it's a skinnier graph than normal. So we can just draw the graph like this. We don't need to label we don't need to put a dot on the y-axis at 21 because it would go off our paper anyway. So we know though that because of this chart we see 0, 21 is the y-intercept, and we know it's up there somewhere. So we know the function is increasing from in the domain. So again, the increasing and decreasing is what we're being asked here is the function is increasing over what part of the domain? Well, from the axis of symmetry to the right, so from negative 3 to the right, the function's values, the function's y values are getting bigger, or the function's values are increasing. And likewise, from negative infinity all the way to the axis of symmetry, the y values are getting smaller. The slope, we don't refer to what's the slope of a parabola, so that's just NA, non-applicable. Maximum value, since the y values continue to get bigger and bigger, we have no maximum value, but the minimum value is 3, and the axis of symmetry again is x equals negative 3.